What would happen if the Earth experienced a sudden cataclysmic crust shift? I'll give you a hint, it wouldn't be pretty. But as we speak, our planet is constantly undergoing changes in its magnetic field. But this happens gradually. So gradual, in fact, that you can hardly detect it. So let's define the difference between a crust shift and a magnetic pole shift. Our planet is a living, dynamic world, constantly changing and evolving beneath our feet. A complex interplay of forces shapes its surface and interior. This dynamic planet is protected by a magnetic field generated deep within its iron core. This core, enclosed in a swirling mass of liquid iron, acts as a giant dynamo. This invisible shield deflects harmful solar radiation, constantly bombarded by charged particles from the sun. Without it, life as we know it wouldn't be possible. And this magnetic field defines our north and south poles, the familiar points of reference on our globes and maps. These poles aren't fixed, but shift and wander over time. But some theories suggest a far more dramatic event. A cataclysmic pole shift, a sudden and radical realignment of the Earth. This involves the planet's crust suddenly slipping over its interior, like a loose shell shifting on its core. Imagine the continents themselves moving. This relocation of the geographic poles could happen in days or even hours, a geological blink of an eye. The consequences would be profound. This is fundamentally different from the gradual magnetic pole reversal, a well-documented phenomenon where the magnetic north and south swap places. Magnetic reversals are slow, drawn-out processes taking thousands of years to complete. They are driven by changes in the Earth's core. Imagine the skin of an orange sliding over the fruit, a sudden dramatic shift in position. In such a scenario, cities in the tropics could end up at the poles overnight and vice versa. The climate and geography would be unrecognizable. While dramatic and captivating, most scientists view rapid crustal shifts as highly speculative, lacking strong evidence to support their occurrence in recent geological history. Still, exploring these ideas, however far-fetched they may seem, helps us appreciate the delicate balance of forces that shape our world and the interconnectedness of Earth's systems. Our planet is not a static stage, a fixed backdrop for the drama of life. It's an ever-changing body with a turbulent history, marked by volcanic eruptions, earthquakes, and the slow, relentless movement of tectonic plates. In this journey, we'll separate fact from fiction, carefully examining the scientific basis for these claims. We'll explore what could cause such shifts, delving into the potential mechanisms that might trigger such a dramatic event. And we'll look at the evidence, or lack thereof, in Earth's geological record, searching for clues in ancient rocks and sediments. Understanding these planetary mechanics, the intricate dance of forces that govern our planet, connects us more deeply to our home in the universe and our place within it. So, let's dive into the science, the established theories, and the cutting-edge research. And the speculation, the what-ifs and the possibilities behind pole shifts, separating what we know from what we only imagine. If you enjoy learning how our world works, then take a second to subscribe to my YouTube channel. And of course, watch some of my other videos on the cosmos and our planet. Thank you. What could make Earth's crust slip so dramatically? Charles Hapgood theorized that massive polar ice sheets could unbalance the planet, causing the crust to slide over the mantle. But the friction between the crust and mantle is immense, far too great for even the largest ice sheets to overcome. Some have imagined a rogue planet or asteroid passing close by, its gravity wrenching Earth's crust loose, but there's no evidence for such an event. Mainstream science finds these scenarios implausible. The forces binding our planet are simply too strong. The real story of Earth's change is written in slow, powerful movements, not sudden catastrophe. There's a crucial difference, a world of difference in fact, between a cataclysmic crustal shift and a magnetic pole reversal. These are two distinct phenomena that often get conflated, leading to unnecessary alarm and misunderstanding about our planet's dynamic processes. The crustal shift is the hair, a sudden burst of geological upheaval. It's sudden, violent, and catastrophic, a rapid reshaping of the Earth's surface. It's a concept that captures the imagination, but remains highly speculative, lacking solid evidence to support its occurrence in recent geological history. The magnetic reversal, on the other hand, is the tortoise, a process unfolding at a glacial pace. It's slow, steady, and scientifically documented through the study of ancient rocks and their magnetic signatures. Magnetic reversals unfold over thousands of years, a gradual shift in the Earth's magnetic field. During this time, the field weakening and multiple poles appearing across the globe, creating a period of magnetic uncertainty, before settling into a new orientation, with the magnetic north and south poles essentially swapping places. A crustal shift, if it were to occur, would move continents, drastically altering the geography of our planet. In contrast, a magnetic reversal only changes compass directions, a relatively minor inconvenience in the grand scheme of things. Paris would stay put, its location unchanged by the magnetic field's behavior. But your compass might point south instead of north, a simple adjustment for modern navigation systems. These two ideas get confused because both involve the poles, the geographical poles, and the magnetic poles. But their mechanisms and consequences are worlds apart, representing vastly different scales of geological and geophysical processes. One, the crustal shift, remains a fringe theory, largely unsupported by empirical evidence. The other, the magnetic reversal, is a natural cycle in Earth's history, a well-documented phenomenon that has occurred countless times over millions of years. Understanding this distinction is key to grasping our planet's true nature, appreciating the difference between speculative ideas and established scientific facts. Earth's magnetic heart is always changing, a dynamic system that protects us from harmful solar radiation. But the ground beneath us is far more stable, a testament to the resilience of our planet and the slow, steady processes that shape it over vast stretches of time. If a sudden crustal shift did occur, the results would be apocalyptic. Oceans would surge, creating mega tsunamis that sweep across continents. The land would convulse with massive earthquakes and volcanic eruptions, darkening the sky with ash and plunging the world into a volcanic winter. Climate zones would shift overnight. Tropics could freeze. Temperate cities could become polar wastelands. Ocean currents and weather patterns would collapse, making survival nearly impossible. Ecosystems would shatter, triggering mass extinctions. Humanity's infrastructure would be obliterated in hours. While this scenario is scientifically unlikely, it's a stark reminder of our dependence on geological stability. The power locked within our planet is immense. We take stability for granted, but Earth's forces are always at work. Catastrophe, though improbable, is a powerful thought experiment. A magnetic pole reversal is far more likely, and its effects would be profound for our technology. During a reversal, the magnetic field could weaken to just 10% of its strength, leaving us exposed to cosmic and solar radiation. Satellites and power grids would be vulnerable to solar storms, risking global blackouts and communication failures. Animals that navigate by magnetism, birds, turtles, whales would lose their way, disrupting entire ecosystems. Humans would face increased radiation, raising health risks like cancer. Our atmosphere would still protect us, but the long-term effects are uncertain. It wouldn't be an instant apocalypse, but a slow, creeping crisis. Adapting to a weakened magnetic shield would challenge our technology and resilience. The magnetic field's slow dance shapes life on Earth in subtle, powerful ways. How do we know magnetic poles have flipped? The evidence is in ancient rocks. When lava cools, magnetic minerals lock in the direction of Earth's field, creating a permanent record. Geologists have found that Earth's magnetic field has reversed hundreds of times, though not on a set schedule. The last full reversal was 780,000 years ago. We may be overdue for another. The magnetic North Pole is currently racing towards Siberia, a sign of the core's restless motion. Navigation systems already need frequent updates. There's no evidence for rapid, catastrophic crustal shifts, just a slow, wandering magnetic field. Earth's story is one of gradual change, not sudden disaster. The Earth's magnetic field, our invisible shield, is in constant flux. But what would a magnetic reversal look like in real time? It's a question that blends scientific understanding with a touch of speculative imagination. Let's try to visualize this slow-motion catastrophe. Over centuries, the field would weaken, gradually losing its strength and effectiveness. The protective bubble around our planet would become thinner, more vulnerable, and the magnetic poles would wander erratically, no longer fixed points of reference. They'd embark on unpredictable journeys across the globe. This wandering would force constant updates to navigation systems as maps and instruments struggle to keep pace with the shifting magnetic landscape. Auroras, those mesmerizing displays of light, would appear at unusual latitudes, gracing skies far from their traditional polar homes. Imagine seeing the northern lights in Rome. Consequently, animal migrations, guided by the Earth's magnetic field, would falter, leading to confusion and disorientation among creatures great and small. After 1,000 years of this decline, the field might be just 30% as strong as it is today, leaving us significantly more exposed to the sun's radiation. Compasses would spin uselessly, unable to point to a stable north, rendering them obsolete for navigation. Modern technology, so reliant on a stable magnetic environment, would struggle to cope with the fluctuations and weakening field. Solar storms, normally deflected by our strong magnetic field, would cause frequent and widespread blackouts, disrupting daily life and essential services. Society would be forced to adapt to a more hostile environment, developing new strategies for protection and resilience. At the reversal's peak, the magnetic field could drop to a mere 10% of its original strength, leaving the planet vulnerable to the full force of cosmic radiation. This would expose the planet to significantly more radiation from the sun and deep space, increasing risks to human health and ecosystems. But humanity is nothing if not adaptable. We would adapt, living more indoors, seeking shelter from the increased radiation levels. We would rely on radiation-hardened technology, designed to withstand the harsh conditions. And we would change how we communicate, perhaps relying more on fiber optic cables and less on vulnerable satellite systems. After millennia, the magnetic field would slowly begin to stabilize, regaining its strength and influence. But with a fundamental difference: reversed polarity. North would become south, and south would become north. Life, resilient as ever, would adjust to the new magnetic orientation, finding its way in a world where compasses point the wrong way. And eventually, the planet would be protected once again, shielded by a renewed, albeit reversed, magnetic field. The challenge of a magnetic reversal would be long and difficult, testing the limits of our ingenuity and resilience. But it's crucial to remember that such an event, while disruptive, is not the end of the world. It's a natural process, and life, in all its forms, would find a way to thrive. After a full magnetic reversal, humanity would emerge changed. The continents would be the same, but our relationship with the cosmos would be transformed. We'd have adapted our technology and society to a harsher radiation environment, robust power grids, radiation-hardened electronics, and new ways of living. The experience would become a defining chapter in human history, shaping our culture and worldview. Ecosystems would recover, and surviving species would adapt to the new magnetic regime. We'd learn humility and resilience, recognizing our place as passengers on a dynamic planet. The world would carry the memory and the lessons of surviving a cosmic test. Contemplating pole shifts gives us a cosmic perspective, reminding us that Earth's stability is never guaranteed. Geological time dwarfs human time. A magnetic reversal may take millennia, but it's a blink in Earth's history. Life has survived far greater traumas, always finding a way. Our challenge is to build resilience, robust technology, shielded satellites, and a deeper understanding of our planet. The real threat isn't sudden catastrophe, but our ability to adapt to slow, inevitable change. Studying pole shifts connects us to Earth's deep past and uncertain future. We are the first species able to understand and prepare for these cycles. That knowledge is both a responsibility and a promise for humanity's future. Thank you for watching, and please subscribe to help my channel, and as always, stay informed.